Hey, welcome back. AP Stats, Statsmatics Lessons, Mr. Hayes, Stats student in the back. All right, so we're going through the probability lessons, and we're on the third one, so this is day 3, and we're going to talk about who's going to win the last banana, and this is based off of, if I remember correctly, one of a TED Talk. It's kind of one of those interesting setups because, and if you've ever gone, well, if your parents have ever gone to Las Vegas, a lot of the games are actually, even at carnivals and stuff, a lot of the games look like they're relatively fair, but they're really not. In fact, Vegas, if I remember correctly, Vegas wins, the house wins 52% of the time, but that's enough because they do enough volume that they go through and they win. So that number I'm just remembering off the top of my head. So my apologies if it's not accurate if you go looking that up. Anyway, moving on. Here's the game. Suppose that you're on a desert island and you're playing dice with another castaway, because what else is there to do? You don't have internet access. The winner's prize will be the last banana. Here are the rules of the game. Each player rolls 1 dice. If the largest value between the 2 dice is 1 through 4, then player number 1 wins. If the largest value shown is a 5 or a 6, then player 2 wins. So again, it's kind of looking like, oh, well, first of all, ask yourself this, who has the advantage? Who would you want to be if you had a choice? So make your best guess. And so the students would go ahead and they write their stuff down, because again, this is the situation where, again, it doesn't matter which way you say it, just we want you thinking about what works best. So you're going to play the game 20 times. So we have pairs of 2 kids. So in my class, I think this one, if I remember the data that I put down correctly, I think we had 24 kids that day, so we had 12 pairs. So they go through and they play and they record the winners of each game. So one of them that we did looked like this. Okay, player A won 40% of the time, player B won 60% of the time, because we had 8 out of 20 and we had 12 out of 20. Okay, so wrote out our proportions. Hey, Mr. Hayes, this isn't tough yet. Good, it's not supposed to be. Remember, statistics is primarily using math, not necessarily coming up with new ways to do it. So then, who won more often? Maybe this is only true for you. So we start putting this up on a table. And this is what I saw last year. 106 out of the 240 games, player A won. And 134 out of 240 games, player B won. And so we had a 44.2% chance that player A was going to win, and 55.8% chance that player 2 won. If I remember correctly, we had more people up here say that they wanted to be player A. And why? Because they had 4 numbers and not just 2. Needless to say, the people who were player B were very, very happy. So to determine the true probability of player 1 winning, we need to list out all possible rolls. Okay. So to list out all probable rolls, we have this table over here. And so it starts off like, so this is going to be 1 and 1, this is 1, 2, et cetera, et cetera, et cetera. So you're going to look and go through that. So you're going to use the table to see what the probability of player 1 winning is. So now remember, player 1 means that the highest number can be a 4. So that means that this number right here, so this is all the ones that have 4 or less. Okay, so that is player 1. So that means I have, 16 out of 36. And that gives me an answer of 4/9, or 0.444. So about 44.25%. Which actually matches up close to what I had. This is, I think, one of the few times my classes actually hit it. Normally, I always have a few outliers, shall we say. So which was closer to the probability that you found? 4A, your group data or the classroom data? So which one did better, your group or the classroom? Our group up here only had 40%. Down here, classroom data was 44%. So anyway, why do you think that is? So the class data more games were played. You might remember what that was called. Remember, always do your notes or your highlights and something else. So this was called the, say it with me, law of large numbers. All right. And so that's the experience. Like, what's going on? That's crazy. So we're going to go through and we're going to formalize this here in a second, and then I'm going to come back and we're going to point out which is which here, because we're starting to lay down and describe different types of probability. It is going to be imperative for you to make sure you keep this vocabulary in mind, because I don't want to say it's nuanced, but they're close enough that it's easy to get confused if you're not paying attention. All right, so we'll see you soon. If you have any questions, throw me a note down below. Talk to you soon.